is it showing up on? Setting up your meeting for YouTube Live. There we go. Whoop. Whoop. Yesterday. Whoop. So yesterday we were going through the values of A, K, H, and B and what they did on the page. Did we get through all four of those? Okay. So I'm going to put this back up here. This is from my second block class, so it might look a little different how I wrote it. Okay. So these were what we were talking about yesterday. Okay. So if you don't have those things written down, you're going to want to write those things down. And those things are true for both sine curves and cosine curves. Okay, sine curves and cosine curves. So while you're checking that out a little bit, sure. Shaka laka. Delete. What was that? Delete that too. And then we need this. So during lunch yesterday, I thought, you know what, I was using that thing with you yesterday where the wheel was unwinding and stuff, and I liked it, but I didn't like it. So I went ahead and just created something of my own to use with you guys instead, which I think is a little easier to kind of follow along with what's happening. So I'm going to drag this over here. And so here is the red one is f of x equals the sine of x. Okay? And we graphed the sine of x, the parent function, yesterday by hand. And all we were doing was going around the unit circle. And in going around the unit circle, we were giving the what values of our familiar angles. What values were we using on our familiar angles? Yeah, the y values. Because the y values are the sine of the angle theta, the rotation. Okay? So that was what all of this was about here was this. And then we saw that it went from 0 to 2 pi, and then the graph did what? Repeated. And we said the amount of time it takes for something to repeat is called the period. So the period of sine is 2 pi. It takes 2 pi radians or 200 or 360 degrees before you're back to where you started and you repeat the graph. Okay? So yesterday we had this, and we talked about what the values A, B, H, and K did. So the value of A, we said it was the amplitude. It changed the height of the graph. So if I change this, I'm going to go ahead and put this on right here. Okay? So here you can see when the amplitude is 1, it's the same as this graph. It's right on top of it. Because the value in front of the sign here is a 1. Okay? And as I increase it, we notice that the only thing that changes is the amplitude of this graph. It just gets taller. It gets higher and lower, right? If I'm bigger than 1, boom. And what do I notice? Like if I make it 2, it's got an amplitude of 2. If I go up to 3, it's got an amplitude of 3. And amplitude, what we say the amplitude was yesterday. What did that mean when I say, oh, the amplitude of the graph? It's about the maximum in, yeah. It's half the distance between the max and the min. Okay? It's half the distance between the max and the min. So here, this max is at positive 3. This minimum is at negative 3. The distance between 3 and negative 3 is 6. And if you divide that by 2, it's what? 3. That's the amplitude there. Now, the reason I say it like that is if I take my graph and move the whole graph up or down, and which of these values moves the graph up or down? Which one? One of these other ones, B, H, or K, shifted it up or down. K does. So watch what happens if I shift this up 1. Okay? All of a sudden, my max is where? 4. Does that mean the amplitude is 4? No. But here, the max is at 4, the minimum is at what? -2. If you find their distance or the difference of those values, what's 4 minus -2? 6. That's the distance between the max and min. And then half of that is 3, which is the amplitude. What did this K value do? It shifts it. It also gives us something else. It gives us the what? The midline. So if K is 1, Y would also equal 1. That's the midline. That's the line that's what? Halfway between the maxes and the mins. There it is. So as K increases, so does Y. It's the exact same value. This is a different graph. It's the midline. So now from the midline to here is a distance of what? 3. And from the midline to the minimum is what? 3. So the amplitude is either, you can think of it 2 ways. It's half the distance between the max and min. It's also the distance from the maximum or the minimum to the midline. Either way, they're saying the same thing. They're describing that. So that was the amplitude. All right, what did the value of B do?
It condensed or stretched it.
Yeah, let's go ahead and look at the value of B. So here we go. So there's our original function. So if I make B 2 all of a sudden, we notice that what happens? The graph gets smushed this way. It's a horizontal compression, it's called. So the cycle from here to here used to take 2 pi radians. Now what's it taking? Pi radians. So the value of B has an effect on the period of the function, how quickly it goes through one cycle. Okay, if I make this all of a sudden 4, whoop, now we see that the graph, I'm going to zoom in here, what do we notice? The graph goes through a cycle in how many radians? Pi over 2 radians. So again, this just changes how quickly it goes through a period because it's a horizontal compression. It smushes it together. It didn't change the amplitude. It didn't change where the midline was. Had no effect on those at all. All it did was smushed it horizontally together, like an accordion or like a slinky. If you have a slinky and you pushed it together, that's what it did. If I make it less than 1, it stretches it. Notice here when I make it 1/2, the period becomes longer. Now the period is what? Now the period is 4 pi. The original was 2 pi. Okay? What does H do? It's the phase shift, also known as a what? Horizontal shift, correct? Okay? So here we'll put B back to 1. There it is. So now let's do this. Let's zoom in here. Okay, my graph, where does my cycle start right now in the sine function? 0, it starts right here. Boom. There's where it starts at. All right. Let's say I make H right here. I'm going to just type in pi divided by 4. Notice where it's at. Where's the graph now starting at? Pi over 4. Now notice it's x. This would be what? X minus pi over 4. But it really shifts it to the right. If I make this a negative pi over 4, it's going to shift it to the, and notice where it's starting at now, negative pi over 4. So this changes the starting position of the cycle. H does. Where does a cycle start? And if it's changing where it starts, it really also changes where it, what? Ends. Does it change the period though? No. Does it change the amplitude? No. Does it change where the midline is? No. It only changes where it starts and stops a cycle. So each of those four variables has something that it will do to the graph. Okay? Each one of those does something to the graph. All right. And again, this is true for both sine and cosine. Now, yesterday, we graphed sine together by hand, didn't we? Did we graph cosine by hand? In this class or not? Not by hand? We're going to right now. And I'm going to do it right below this function here. Okay? So, you guys can go ahead, and we're going to graph y equals cosine of x right here. And let me widen this out again. Okay. So we're going to do this by hand, the cosine curve, see what it looks like. So we're going to graph y equals cosine of, and this time I'll just use theta. Doesn't matter what it's a variable. Doesn't matter what I name it really. All right. So now when we're doing cosine, let's think about this. And my familiar angles are 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, yup. I'm not going to write all those values down. We should know those. Okay? When I'm doing the cosine of an angle, if I go ahead and I draw this angle right here, when I'm talking about the cosine of theta, which variable am I talking about now in the circle? It's the x variable, okay? It's the x variable. So let's go ahead. I'm going to do this one just a little bit different than I did yesterday. So we're just going to create a table of values real fast. Okay? We're going to create a table of values for the familiar angles, and then we're going to plot our points. So I've got, here's my theta value, and then I'm going to have right below that the cosine of theta. And I'm just going to write down my familiar angles. So I've got 0, I've got pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi. We're going to start with that. Okay? So here we go. What is the cosine of 0? 1. What is the cosine of pi over 6? Radical 3 over 2. I'm just going to remind you, that's about 0.85. Radical 3 over 2 is about 0.85. Pi over 4, what's the cosine? Radical 2 over 2, that's about 0.7, roughly. Okay? Pi over 3, what's the cosine? 1/2, so that's 0.5. Pi over 2, what's the cosine? What's the x value here? 0. All right. 2 pi over 3, what's the cosine? -1/2. 3 pi over 4, it's going to be at negative radical 2 over 2. So it's at negative 0.7. 5 pi over 6, it's at negative radical 3 over 2, which is negative 0.85. At pi, it's going to be where? Negative 1. Okay? All right. So let's go ahead and I'm going to draw another down here. We'll just do the exact same thing for the next part of this graph. Should we do? So now my next one after pi would be 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2. And if you're wondering where those are coming from, they're the familiar angles. Okay, boom, here we go. Doing the same thing. 7 pi over 6. Isn't this going to be the same as this? What was that one? Negative 0.85. What's this? Negative 0.85. 5 pi over 4 is going to be the same as 3 pi over 4. So it's at negative 0.7. 4 pi over 3 is the same as 2 pi over 3 for the cosine. Their x coordinates are the same. That's negative 0.5. 3 pi over 2. 0. 5 pi over 3 is the same as pi over 3. 0.5. 7 pi over 4 is the same as pi over 4. 0.7. 11 pi over 6 is the same as pi over 6. 0.85. And of course, 2 pi is the same as what? 0, so it's 1. Great. Now I'm going to graph this. Now I'm going to sketch my graph of this thing. Okay? All right. So, my largest output is positive 1. My smallest is negative 1. Here, of course, is 0.5. Here, of course, is negative 0.5. Here, now this, so these are this is the cosine of theta. This is theta now. This axis is the theta axis. So it starts at 0 and it ends at 2 pi. And then, of course, about halfway between those, right about there, is pi. And right about here is pi over 2. Right about here is 3 pi over 2. Right about here would be pi over 4. Right about here would be 3 pi over 4. Right about here would be 5 pi over 4. Right about here would be 7 pi over 4, right? Those are those values. This is all we're doing is putting on the x-axis the angles from the unit circle, our familiar angles. I'm not going to put all of these marks. I just know there's one about right here, and there's one about right here as well. I'm just going to put, I'm not going to fill them in. I'm just going to put little marks for those. Great, there we go. Let's start doing this. Here we go. My graph is going to start, whoa, didn't mean to do that. My graph is going to start at what? Where's my first point going to go? 0, 1. Boom. There it is. Pi over 6, I'm at 0.85. So it's right about here maybe. It's an estimate. At pi over 4, it's at 0.7. So maybe right about there. At pi over 3, it's at 0.5. At pi over 2, I'm at 0. Okay? Now I'm down here. So this is the first part of my graph, guys. There it is. There's the first part of my graph. Now I'm here. 2 pi over 3, where am I at? Negative 0.5. So it's right about here. Oh, move that over. Right about there. Then where am I off to? Negative 0.7 roughly. And then where? Negative 0.85. And then what happens at pi? Where am I at? Negative 1. So then it goes like this. And then what happens? The values do what? Repeat and go back up towards 0. So I have one right here, like this maybe. And then I've got this guy is right here. And I've got this guy is right here. And then it's back up here. So now I'm through what? I just finished, I'm right here. That's where I'm at, 3 pi over 2, 0. Then I go back above again. About right here, right? A little bit higher again, and it finishes at what? 1. And it goes like that. Okay? So that's like the first cycle of a cosine curve. All right? Again, this is all about knowing the unit circle knowing all the coordinates and knowing that the sine is the y and the cosine is the x. That's how we're creating these graphs, right? Now I'm going to go back. I just want to show you this. So here is from yesterday. I did this as well, okay? And I did them on the same page yesterday. So real quick, what I want to do here, I'm going to real quick take this and group this. And I'm going to drag this down on top of this. And do we notice anything? Their shapes are the same. Their periods are the same. Their amplitudes are the same. The only thing is that they're off center from one another, if you think of it that way. How far off center are they from one another? What is this distance from here to here? Pi over 2. Okay? From here to here is pi over 2. From here to here is pi. From all of those are like that. Okay? It's a shift. In other words, if I took this sine curve and I shifted it pi over 2 to the left, if I did this, then the graphs would do what? Well, that was nice of it to go break apart. Like, I wish it wouldn't do that. I'm going to hold it. Then it would do what? Yeah, they would pretty much, they should almost line up exactly. Mine are different because I sketched a bunch of different things. And it's also a little bit, oh, look at that. Almost. There it is. They would match up and they would be the same. Okay? This part of the graph from here to here would be the same. So we need to understand that sine and cosine curves are related to one another. Okay? They are related to one another. They are just horizontal shifts, pi over 2 radians, either left or right, and it's depending which one you are shifting. If I want to shift the cosine curve, I'd have to do what? Move it to the right pi over 2. If I wanted to shift the sine curve, I'd have to move it pi over 2 to the left. But then they'd be exactly the same. So what I'm telling you is this. If I go back to what I was showing you earlier, this thing right here, okay? If I were to go ahead here, let's say this is the sine of x. I'm going to turn this stuff off. Down here, I'm going to type in the following. Y equals the cosine of x minus pi divided by 2. What do you notice? It went right on top of the other graph. Which tells me that when I'm given a graph of a sine curve or a cosine curve, I can write it either way that I choose. I can write it as a sine function, or I could write it as a cosine function. That is completely up to me. It's all about the horizontal shift, the phase shift on there. Okay? So we need to understand that. All right, so right now, what questions do you have from yesterday or today? Is there any question that you want to ask? Something that you would like clarified? No? Okay, so one more time, this is a new thing. I tried to create more and more things so that I could, not that one, where is it at? I have one more thing I'm going to show you here. Here it is. Okay. This is a beautiful thing. So this is the what? What do I have here?
Unit circle.
This is the unit circle. Okay. So all I want you to do is notice down here it says sine function. Okay. Now this says t and then r sine of t. Okay. So all you're going to do is watch this. So notice. I'm going to graph this, and here I'm going to turn on my graph, okay? And then I'm going to play this. So I want you to look at what's going on there, right? So you'll notice on this, as this is moving around, I'm going to stand over here, okay? So notice that as this is increasing, as this is moving up, and as this is moving up, it would be the y values would be doing what? Increasing. This graph is doing what? Increasing as well, okay? Increasing as well, and it goes up, and then as soon as this gets up here, it hits its maximum. Because that's the maximum value of y on the circle. That's the maximum value on this graph. Guess what this part of the graph is? This is nothing more than quadrant 1 of the circle. Then we're going to graph quadrant 2 of the circle. And quadrant 2 of the circle is going to stop right about there. Because what happens when you get down here? The y value is what? The y value on the circle here is 0. And now here the y value has to equal 0. Then we're in quadrant 3. And we noticed that it was going down, and then here was -1, here was -1 on the y-axis. And then we go back up, and we get to the very end, boop, and we're at the end of our cycle 2. When this makes one full cycle, this graph makes one full cycle. Now, what's the radius here? 1, because it's a unit circle. Watch this. Let's say I change the radius on this. Here, r is the radius. I just want you to watch. Let's say I make the radius of my circle 2. Did you notice anything about my graph? The purple graph, what did it do? It changed the amplitude. That means the radius of the circle relates to the amplitude of the graph. The radius of the circle is the amplitude of the graph. Whoa, that's pretty cool. So if I made this radius 4, my amplitude will be 4. And notice it. Here the radius is 4. Boop, amplitude is 4 all of a sudden on this. So the radius of the circle that you're working with is nothing more than the amplitude of the sine or cosine curve. And changing the radius, did it have any effect on the period? No, because that's the same as changing the amplitude. All that does is changes what? Maxes and minimums. Okay? Maxes and minimums. And the same thing would be true if I wanted to down here. Let's just go back to 1. Let's go ahead and turn the sine off, and let's instead look at the cosine here. Okay? Here's the cosine curve. There it is. Notice right here on the cosine curve. Okay, I'm going to take this back to 0. People get really confused. Remember, when I'm talking about the cosine, I'm talking about the x value on the circle. Here the x value is 1. On my cosine, though, it's the y value that is 1. So this starts here. So watch what happens. When I'm here, my x values are going to decrease. That's why this graph is going to decrease. There it is. And then my graph continues to go. And then it stops here. At this point here, what happens? What's x here? -1. That's why this is down at the bottom at -1. And then it continues to go back up. Because my x values are doing what here? They're increasing. They're going to the right. So these x values are going to increase. This is going to come back up. And then here, of course, x equals 0. That's why it's back on the x-axis over here. And then it continues to go to the end. Boom. And then if I turn them both on, if I turn on the sine one as well, you can literally see that they are related to each other. Okay? Notice the graphs. Can somebody tell me where they're intersecting? When those graphs, see how they cross right here? They cross there and they cross there. When is that happening? What angles? Where are the x and y coordinates the exact same? Pi over 4, that's quadrant 1. And where else does that happen? Quadrant 3 at 5 pi over 4. That's where they're crossing at. Okay? How are we feeling? Do we have some of an idea here what's going on? If you're not, you're going to have to speak to me on your own, okay? So, let's start doing some graphing here. And I'm going to show you, when I ask you to graph, because I will ask you to graph some by hand to make sure you understand what these numbers are doing. We're going to do it in a very simple way. I'm going to teach you how we're going to do this, okay? So let's go ahead and, why is it not? Okay, here we go. So, let's look at this one. So on this one, we've got those values of A, B, H, and K. All right? So whenever on sine, guys, on the original sine function, A and B are 1, H and K are 0. Okay? So I look at this, and I say to myself, okay, what are the values of A, B, H, and K for this function up here? Just tell me what they are. What's A? 2. What's B? 1. It's the what? It's this value right here in front of X. It's 1. Boop. What's H? 0 and 0. Okay, now look, what do I know then? It's got a radius of 2, which means its amplitude is 2. Okay, so I know the amplitude is 2. I know B is 1, and B does what? Changes the period. So right here, the period is always 2 pi divided by B. Always, always, always if we're in radians. So for us, it's 2 pi divided by 1, which means what? So that means it will complete one cycle in 2 pi radians. Okay? Easy enough. All right. This tells me where the cycle is going to start. So this one, I'm going to start the cycle at 0. And when I say 0, I'm going to put down at theta equals 0. Or in this problem, I guess it's x. I shouldn't change variables. At x equals 0. So I'm going to start at. There's no horizontal shift. What does the k value give me? The midline. Yep. This is telling me the midline is at y equals 0. If that's true, and the amplitude is true, it means I'm going to have a max of 2 and a minimum of -2. So my max is going to be 2, and my minimum is going to be -2. These are things I would be thinking in my head as I'm graphing these. These are my thoughts. I'm writing them down now. It doesn't mean you're always going to have to write them down, but right now we're just writing them down. These are the things I know about this graph right here. All right, great. So we're going to start graphing this. Okay, now, there are 5 points you're going to give me on your graph. 5. That's it. 5 points. These are like the critical values that you're going to give me, or the important values, sometimes they're called. Okay, and I'm going to show you where they're at. The important parts of the graph, and this is a sine curve, and right now, automatically, as soon as you see a sine function, you immediately need to see this shape in your head. That has to happen in your head for a cycle of sine. The important values are these: 1, 2, 3, 4, 5. Those are the important values. Where does it start? Where's the max? Where does it come back through the x-axis? Where's the min? Where does it come back to the x-axis? Let's think about these. Where are these at? This is at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are the ones I'm most concerned with. They give me the shape of my graph. I don't have to do all of the other ones to get a sketch of a graph. So it's a 5-point method. It's a 5-point method we're using here. Okay, here we go. So I'm going to put, I know that my period is 2 pi, and it's going to start at 0. So I need to go, here's where it's going to start at. I know that. And it's also going to end at 2 pi. Okay, great. My y-axis needs to go how high? Positive 2. All right, great. So here's 1, here's 2. Here's negative 1, here's negative 2. Okay, let's go ahead. The only other points I'm going to put on here are pi, pi over 2, 3 pi over 2. And we're going to keep graphing this. Here we go. All right, so I got this one here. I got this, so we're just going to stop and start. Okay, now what do I know? Halfway between 0 and pi, what do you get? You get the maximum. What's the maximum going to be on this? 2. So right here, I'm going to go up 2. So when I see a sine curve, sine goes 0, it's a 0, max, then back down to a, what again? What's this? What is this called? These are called the what of the function, guys? Zeros. That's a max. This is a min. So it goes 0, max, 0, then what? A min, and that's going to be at negative 2, and then 2 pi. My graph would look like this. There it is. Okay, there it is. I've got my graph. It's beautiful. I love it. If somebody looks at this, they would say, if they've ever had this class, they'd say that's a sine curve. Oh, it's got an amplitude of 2. Oh, the period is 2 pi because it's completing a cycle. They know there is no horizontal shift, and they know there is no vertical shift. Now, the one thing I could do, it's not as important here, but the one thing I could do if I wanted to add it in is I could do a what? Midline here at y equals 0. I could put that in, and that's more important if there is a vertical shift up or down to have that midline drawn. If it's just, this is the word oscillate needs to go around. If it's just oscillating above and below the x-axis, it's not as important to do that. Once you start shifting it, though, it's more important to draw the midline. Okay, boom. 5 points. We used 5 points on this. All right. Any questions on this graph, how we got it? All right, here we go. So this is a cosine curve now. Cosine of x plus 1. Oh, when you come back, we'll keep going with this. Or when I come back, because I'm the only one that ever leaves. Oops, I'm sorry. How's your day? Like, no, man, so I'm like, oh, this is weird. Okay, here we go. So we're back to this guy. So I'm looking at this cosine curve. As soon as I see its cosine, I immediately in my head am seeing the following graph. I'm seeing this graph instead, right? Okay, I'm seeing this graph instead. So cosine starts on a max, ends on a max. Whereas sine starts on a 0, ends on a 0. So I'm immediately remembering the shape of the graph in my head. Okay, so here we go. So we've got values of A, B, H, K. A is 1, that's nice. B is 1, that's nice. H is 0, that's nice. K is 1. All right, so this time the K value is the midline. So I'm going to start getting ready to sketch this. I'm not going to do the whole thing yet, but all I want to do is I want to get the midline drawn right now. I'm going to draw the midline first on this since there's a shift, vertical shift. The midline is at 1, so here it is. So my midline is going to be right here. At y equals 1. All right. So here we go. Since A is 1, the amplitude is what? That tells me my max and my min. Thank you. The max is going to be the midline plus that, so that's going to be at 1, and the minimum is going to be the what? Midline minus that, so I'm going to be at 0. So my maxes are at 1, my min's at 0. All right. B is the period, so what do I know? I know the period for this is 2 pi over 1, which is just 2 pi. So it's got a regular cycle as far as how long it's going to take. And H, there is no shift left or right, so that means it's going to start at 0. It's going to start at 0 and it's going to end at 2 pi. Here's 0. I'm just going to come down here. I'm going to put 2 pi. And every time I know where it starts and stops, I always divide it then the same way. I do what? I take these and I cut that in half, and I label it. Half of this is pi. Then I take each piece of that and cut it in half. I cut this piece here. This would be pi over 2. And I cut this piece here, which would be 3 pi over 2. Okay? So, here we go. Let's graph it. It's cosine. Cosine starts at a maximum. So, it's going to have a max of 1. Is that right? The max is 1?
No.
Oh, the max is 2. I thought somebody said 1 earlier. So, the max is at 2. So, here's this. I have to go up. Here's 2. So, it's going to start here. It's also going to end there. Okay? Can somebody tell me where the minimum is going to occur? Where on the x-axis is the minimum going to occur? Pi. Halfway between the maxes. The min is always halfway between the maxes. So the min's going to occur here. What is the minimum value?
0.
So it's going to be right here. What's going to happen between the maxes and the mins? It's going to cross over the midline. So it's going to cross over the midline at pi over 2, and it's going to cross over the midline at 3 pi over 2. So that means now that this graph would go, and I have it. There's a cycle of the cosine curve. So the first one had a change in amplitude. This one had a vertical shift on it. Questions on either one of those? Anything I did? No? Okay, here we go. Oh! Little change on this one. So let's go through and write down our values. So we've got A, B, H, and K. What's A? 1. Okay. What's B?
2.
What's H?
0.
0. What's K? 0. Okay. Now, once I have those written down, now I'm going to go back up here and do my max and min. Because this is my midline. So I know right now that this is going to have a max of 1, and it's going to have a minimum of -1. We all agree on that?
Yeah.
All right. Where's it going to start at?
0.
If there's no horizontal shift, where does it always start? What? What angle does it always start at, guys? Where does the unit circle start at? Standard positions where?
1.
Angle. Angle. If I draw an angle in standard position, where do I start at?
0.
0. This is telling me what angle I'm going to start at. I'm starting at, this is an angle, guys, because remember, it's being added or subtracted from the angle in here. So I'm going to start at 0, and this is B in radians. That's how we're doing this problem. Okay? And then, of course, the midline is y equals 0. All right. Let's go back up to this one now. This is huge. Here we go. Right here, the period is going to be 2 pi over what? 2. If I simplify that, what's that mean? Pi. Okay, so this is going to go through a cycle in pi radians. Now let's think about this. If I'm going to start at 0 radians, and it's going to take pi radians to go through a cycle, all I do is take start plus the period. So where's it going to end at? It ends at 0 plus pi, which is pi. Again, why did I do this? This is where it starts at. This is the what? This is the period. What I literally did here, guys, what I've done here to find out where it ends at what? The h value, the shift, plus the period. That's how you find out where it's going to end at. Where does it start? Plus the period gives me where it's going to end at. Okay. I think I have enough to graph this. Alrighty. So usually I would put 0 here, and way down here I'd put 2 pi. That's great. But I really don't need that, do I? I only have to go from 0 to pi. Okay, I'm going to do that right there. There's pi. Now, this is a sine curve. What do I know about sine? Sine goes, right? That's what it looks like. Okay. So here's where it starts. Here's where it ends. So now I take this and I divide it up into pieces, right? I start by doing what? Cutting this big piece here into half. So that means right here, I'm going to be at what? Pi over 2. Then I cut each of those little segments in half. What's half of this piece? Pi over, what's half of between 0 and pi over 2? Pi over 4. What's halfway between pi over 2 and pi? 3 pi over 4. Think about it on the circle, guys. Here's pi over 2. Here's 0. Here's pi. Halfway between those two, pi over 4. Halfway between these is 3 pi over 4. My cycle is going to go from here to here and stop. Right now, I already know it's going to start here and it's going to stop here. Okay, great. I'm going to draw the midline. I might as well. There's the midline. All right, let's graph this thing. Here we go. We know that sine starts on a 0. Starts on the what? Midline. That's where it starts, on the midline. So it's going to start here, and it's also going to end on the midline. And guess what happens? Halfway between those, it's also going to hit the midline. Because it hits the midline 1, 2, 3 times. All right. What happens between the first two? A max. And the max of this is going to be what? 1. So I'm going to go up 1, and I'm going to put a point. Halfway between the other ones, it's going to be at the minimum. And I'm going to put my dot. Here it is. There's my graph. No, I only did it, and there's a reason I did it. You don't have to, okay? Now, what would happen, this is the first cycle. If I said, hey, what would the next cycle look like? What would it look like? It'd be the exact same as this one. It'd be this thing right here, and it would just be like this. And it would end at 2 pi. And this would be at pi, this would be at 3 pi over 2, this would be at 5 pi over 4, this would be at 7 pi over 4. Okay? I'm asking for one cycle for sure. If I asked for 2, it would just be extending it on. That's the only reason I did it this time, just so you would understand it. That's not the entire graph, right? That's just one cycle of an infinite number of cycles, infinite number of times. So if you're giving me a graph, what are the important things to show me? You have to show me these values here where it intersects the midline, where the maxes are, and where the minimums are. That way I know you have the correct things. You also have to show me what? The values on the y-axis, so I know you have the correct what? Maximum and the correct minimum, which means then you have the right correct amplitude. Okay? So this part right here, this is a must for me to know what's going on in your graph. That's how I know if you know for sure what's going on. Any questions on this one? Do another one. Here we go. Okay. So this one, let's just talk about this one right now. Okay. Where's the midline at for this one? 0. So I'm going to just draw the midline. And I'm going to do it the same way. I'll go A, B. I'm just going to write it like this instead, no sense I do that up there. So what's A, the amplitude of this bad boy? 1. It's got a normal amplitude. What's B? 3. What's H? 0. What's K? 0. Okay, so now I know. So this right away gives me the midline. So I'm going to start by drawing the midline. The midline is y equals 0. So I'm going to draw that first. Okay. We know it starts where? Starts at what? Where does it start, though? The graph. Where's my cycle going to start at? What value of 0? It's going to start at 0. So I'm going to put my 0 here for it to start at. Now, in a second, we're going to find where it ends. Before I can find out where it ends, I have to know the period. Here's B. What is the period of this thing going to be? 2 pi divided by 3. That's it. You leave it like that. So this thing's going to start at 0, and it's going to end where then? 2 pi over 3. And end at 2 pi over 3. Boom. So here's 0. Here, I'm just going to say right about here is 2 pi over 3. Okay? Are we okay with that? Now, and of course, on this one, we know A is 1. So I'm going to go, if A is 1 and the midline's at 0, that means I'm going to have a maximum of 1 and a minimum of negative 1. Okay? So I can put that here if I want. Max equals 1, min equals negative 1. Okay, great. Now, what I have to do at this point in time is I have to divide this little section up because the cycle is going to occur in here. So what do? I start by taking this and dividing it in half. So what is going to be halfway between 0 and 2 pi over 3? Pi over 3. Boom. Okay? It's just take this times what? 1/2. That's all I had to do. Now I take this and multiply it by 1/2 to find what's halfway between here, which is pi over 6. Where's this one going to be at then? I'm sorry, say it again. Pi over 2. So look, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. They're all going to be perfect. Now, okay. It's not bad. I like that. Now I can do what? Sketch my graph. Let's do this. Let's sketch this bad boy. Okay, it's a cosine. Cosine starts on a maximum. So it's going to start at 1, and it's also going to end at 1. So it's going to have a max 0 at angle 0. It's going to be at 1, and at 2 pi over 3, it's going to be at 1. Where's it going to be at negative 1? Pi over 3, halfway between them. Where's it going to cross the midline? Pi over 6 and pi over 2. So this one looks like that. That's one cycle of it. That's one cycle. How many cycles would it go through before I get to 2 pi? 3, right? It would go through 3 cycles to get to 2 pi. Because I'm doing what? 2/3 of the original amount. Okay? I'm doing 1/3 of the original amount. There's my graph. Okay. You gotta ask questions. Oh boy, different. Now we've got a what? We've got a value of h that's not 0. So a and b and k, they're the normal amounts for the parent function. We've got a what? Phase shift on this. So on this, a equals 1, b equals 1, h equals what? Be careful. Remember, on your paper, it says what? X minus h. This is the actual shift. Which way is this going to shift? Left. So what is h really? Negative pi over 2. Remember, this is telling me where it's going to start at. And then, of course, the value of k on this is 0. So right away, I know it's got a midline of y equals 0. Which means I know it has a what? A max of 1 and a minimum of negative 1. I also know the period is what? Wait, if b is 1, what's the period? Yeah, the period is going to be 2 pi, right? Yes? All right. Guess what I want to find out? Here's where it's going to start. It's going to end at negative pi over 2 plus 2 pi. Now, whoa, wait. Okay. Negative pi over 2 because that's where the cycle is going to start. Why is it plus 2 pi? Because that's the period of this thing. And that's going to tell me where it's going to end. So, what is negative pi over 2 plus 4 pi over 2? This is really 4 pi over 2. So it's going to end at 3 pi over 2. So my graph is going to go from negative pi over 2 to 3 pi over 2. All right. Here we go. Negative pi over 2. So I'm going to put so for me, I'm going to make my sketch as nice as I can. If this is negative pi over 2, then this is going to be pi over 2. I want it to be about the same distance away. I'm trying to make this sketch as nice as possible. And then I want to go another distance like that, and this would be pi, and then I go another distance like that, and this would be 3 pi over 2. Okay, why do I have 4 pieces always? Why do I have the, and of course, what's here as well? We know 0's in the middle, right? We know that. Okay. Great, love it. It's a beautiful thing. Let's do a little graphing here. Here we go. Midline, y equals 0. Okay, we know that we need a max of 1, so I'm going to put 1 here, and then I'm going to go down -1 here. Love that. It's a sine. Sine always starts on the mid-line. So it's going to start right here. And the sine curve ends on the midline. So it's going to end right here. And then halfway between those, it's going to do what? Cross over the midline. So where's it going to cross over the midline again? What's halfway between these? Pi over 2. Okay. What's going to happen here? It's going to be at a maximum. What's going to happen at pi? It's going to be at a minimum. There it is. Okay. So this time, when I had that horizontal shift, that phase shift, the period's important to find where it's going to end the cycle at. So that's how that period's going to tell us where it's going to end. If we know where it starts and we know the period, we can find out where the cycle is going to end. Any questions on that one? Woo! Okay. Now, graph by the 5-point method. Why the 5-point method? Because that's how many points we've done. Okay? I'd like you guys to just try this one to start. Would you please just try this one? I'm going to give you a few minutes to try it, and then we'll go through it together. Boost. Oh, I think. Take it with you. Just take it with you. Do you have study skills right now or something?
Yeah.
Take it with you and just bring it back 10th period.
Gotcha.
Fair enough? seconds. Let me get this one together. All right, here we go. A value is 2. B value is 2. H is 0 and K is 0. So right here, as soon as I write this one down, my midline then is y equals 0. Then I can come back over here and take care of my max and min. My max equals 2. My min equals -2. 2 above the midline, 2 below the midline. Also, I can find the period. The period is going to be 2 pi over 2, which is pi. And the last thing I can do is, hey, I know it's going to start here. It's going to end at 0 plus pi, which is pi. All right, we can sketch this now. There we go. Let's put it like that. That again. Great. There we go. Okay, here's 0. I'm just going to put pi right here. Okay. Now what do? I'm going to take this and divide it up right away. Pi over 2, pi over 4, 3 pi over 4. Done with that. Now I'm going to go up my axes and label those. I need to go up a max of 2. So here's 1, here's 2, and down a minimum, -2. I can draw my midline. There it is, and now we can graph our function. It's cosine. Cosine starts on a maximum. So right here, it's going to start at 2. And it also ends on a maximum. So it's going to end over here at +2. What happens halfway between the two maxes? It's the minimum. So at pi over 2, it's going to be a -2. And then the other two locations are where it crosses over the midline. So at pi over 4 and 3 pi over 4. So your graph, like that. Okay? Boom. How do I know if it's right or not? I see it's got a max that's right, a min that's right, the period's right, where it's crossing over is right. I know it's right by looking at it. How'd we do? Okay? Yes? All right? So again, 5 points. 1, 2, 3, 4. The 5 points. Let's do another one. Let's try this one. Let's see. So what do we know right now? We know it's going to start at 0, okay? And since the b is 1, we know that the period then is just 2 pi. So it's going to start at 0 and it's going to end at 2 pi. So I'm going to divide this up, 0, 2 pi, here's pi over 2, and here's 3 pi over 2. So those are going to be my 5 points that I'm going to need, those locations. Now I look at this and I know that what? Since the amplitude is only a half and the midline's at 0, it's going to have a max at a half and a minimum at a negative 1/2. So right here, this is the half and this is a negative 1/2. There they are. So now we're going to draw our graph. We've got everything to go. It's a cosine. Cosine starts on a what? Maximum. So it's going to be in a maximum. And then I could just go through this and do it. Maximum, then it goes to the what? Midline, right? Then it goes to a minimum. Then it goes to a midline. And then it goes back to a maximum. There's the curve. Hope I have a harder one for you on here sooner or later. Ooh, this is not too bad. Oh, this is the last. Oh, okay. You have to try this one. Hopefully you have those 4 things right. Okay. So I'm going to start with my midline. So my midline is going to be at y equals 0. Okay, what do I know then? My max is going to be at 2 and my min is going to be at negative 2. So I can put those marks. So here's 1, here's 2, here's negative 1, here's negative 2. These are my maxes and mins. Since b is 1, the period is plain old 2 pi, right? Now, here we go. Where's this graph starting at? Where is it starting? At negative pi. So it's going to start at negative pi, and it's going to end at what? Pi. It's going to end at negative pi plus the period 2 pi, which is pi. So when I graph this, over here on the left somewhere, here's, let's just say that's negative pi. Then over here, the same distance away, I would put positive pi. Now let's divide it up. Half in between these two is what? Whoa, half halfway between negative pi and pi? Is 0. Now halfway between these is negative pi over 2. Halfway between these is pi over 2. Let's get this done. Here we go. It's a sine curve. Starts on the midline. So it's going to start on the midline here. Then it goes to a what? Maximum. Then it goes to the midline. Then it goes to the minimum. Then it goes to the midline. There's my graph. Beautiful. Okay. Tonight, here's what you're going to do. You're not doing all of this. Some of this we're going to use tomorrow at the beginning of class. 3, 4. Not tomorrow, I should say that. Thursday we'll use it. Okay. So, yep. So when you get this, okay, you should be able, right now, from what we've done here today, you should have no problem with anything on the front. Even 7 through 10, where it says write the equation, I believe each one of you could write the equation. None of those have a vertical shift on them. Okay, so trace a cycle where it starts and ends and see if you can write a function. 1 through 4, hey, all I want to do there is determine the amplitude and the period. Nothing else. You're not graphing on 1 through 6. Amplitude and period. On 11, 12, and then on the back, you should be able to do 13, 14, and 15. That's where I want you to stop, is at number 15. Just stop at 15. Okay? I'll post the answers to 1 through 15 tomorrow. I would expect for you to also be looking for a little online assignment on graphing sine and cosine, making sure you understand. And when you come back, we'll look at these and we'll keep moving forward with the graphing, guys. Have a great day, everybody. There you go, my nurses. Off to save people. Page 70.
And then I'll go with a summary, and then read it. That thing that had like the paragraphs, like I read it in slides, right?
See you, True.